Greetings, M squared here, and today we are going to learn, actually I believe that's learning target 7, so my apologies. That should be learning target 7 in this chapter. We're going to solve problems that involve lengths of chords, segments, chords, secant segments, and tangent segments. So our first little theorem here, notice that there's two chords intersecting inside the circle. And we're going to be asked to find one of these little pieces of the segment. So either SV or VT or RV or VQ. And so you need to know this formula. You need to know that the product of the two parts of this segment is equal to the product of the two parts of this one. So you just take this little piece times this little piece and set it equal to this piece times this piece. That's the formula. We'll do an example in a minute. But you're just multiplying these two pieces and you set it equal to the other two pieces. If you don't have two chords, if you have two secants, then the formula changes. Instead of just saying this piece times this piece, it's the outside piece times the whole part is equal to the outside piece times the whole part. So that might be what I would write. I'd say outside times whole equals outside times whole. Okay. Now, when you have a tangent in a secant, the formula is really the same. It's just that the whole thing and the outside of this one are the same. So it's the whole thing times the outside part equals the whole thing times the outside part. Okay? So here we go. We're going to practice. So when I look at this, it's a tangent and it's a secant. So I know that it's the whole thing. That's the whole secant, right? Times the part that's outside the circle. That's the y. And that's going to be equal to the whole tangent times the part that's outside. But in a tangent, it's out. The whole thing's outside. So it's 20 times 20. So when I go to simplify this, I want you to notice what kind of equation I have because it's so beautiful. It's a quadratic equation. And if I move everything to one side and get it where it needs to be, whoops, sorry. I just switched these two around. That should be a plus. And now instead of a minus sign, I'm going to subtract 400 from both sides. So that means it's going to be minus 400 equals 0. So y squared plus 30y minus 400. Now when I see a beautiful number like 400, I think, it's probably factorable. So I go to check. And I usually I'll start with something like 20 and 20. I know that doesn't work, but 20 times 20 is 400. And then I'll go down from there. I'll say, well, what about 20? So I break that down. It's 2 times 5 times 2 times 5. That's 10 times 10, and then I need another 2 2s because that would be 400. So I break it down into its prime factorization, and then sometimes I just look at what about 80? No, that would be 40 and 10. Hey, 40 and 10 work. 40 times 10 is 400, and 40 minus 10 is 30, so this is factorable. But again, if you didn't want to factor it, you could use the quadratic formula. But I like to factor better if it's factorable. So these two have to multiply to get that. So y times y is y squared. 40 times 10 have to multiply together to get 400. I need a negative 400, so I'm going to put a minus 10 and a plus 40, because then when I do my outers and my inners, I get 40y minus 10y to get me that 30y. So then I say, well, what are the two answers? That was me checking my factoring. Well, my two answers are negative 40 and 10, and I can eliminate the negative 40 because this little piece can't be negative 40 long. So now I know that this piece is 10. And then I can check again. Does 40 times 10, so the whole thing is 30 plus 10, which is 40, times the outside part. Does 40 times 10 equal 20 times 20? And the answer is yes, 400 equals 400. Okay, so this is inside. So if it's inside, it's not wholes, it's just all parts. So this one's whole thing times outside, whole thing times outside, but over here it's part times part equals part times part. So it's 8 times 10. Those are the parts of AB, that chord, and then it equals 12 times A, which are the parts of this chord, C, D. So if I divide both sides by 12, then I get 80 divided by 12. Well, I'm going to reduce a little bit. 4 goes into there 3 times, 4 goes into there 2 times, so I end up getting 20 thirds. A is equal to 20 thirds. Okay, and that's an acceptable answer. Remember, you can break it down if you want to. You can say 3 goes into 20 6 times, 6 and 2 thirds. I don't want an approximate answer, but 20 thirds is an acceptable answer. Okay, we have another secant and a tangent. So we're going to say the whole thing. What is the whole thing? It's going to be x plus 9 plus 12, but what is 9 plus 12? It's 21. So now we have the whole thing, x plus 21, times the outside part, which is the 12, equals the whole thing, which is the tangent, times the outside part, which again is the 18. Zoom in a little. Okay, well, so now I want to do 18 times 18, 324. And that's going to be 12x plus, and I don't know what 12 times 21 is, so 252, and that's equal to it. So I'm going to subtract 252 from both sides, and I get 72. So 12x equals 72, so x equals 6. They asked me to find FD. So be careful what they're asking you for. So in order to find FD, I have to put this x back into here, because FD is that whole thing. So what is 6 plus 21? FD equals 27, because 6, which is x, plus 21 is 27. Okay, moving over to this one. Now it's two secants. Whole thing, what is that whole thing? 8 plus x. I always like to mark it if they don't give it to me. What's this whole thing? 32. Then it's just easy for me. So 12 times 32, that's the outside part and the whole thing on the bottom secant. And the top one, the outside part is 8. So I'm going to multiply that by the whole thing, which is 8 plus x. So 12 times 32, let me see what that is. It is 384. And that would equal 64 plus 8x. So if I subtract 64 from this, I'm going to get 320 equals 8x. And if I divide by 8, 8 goes into 32 44 times, so it must go into 320 40 times. So x equals 40, and that is what they asked me for. All right. Again, whole thing times outside part, whole thing times outside part. So what is this whole thing? 21 plus 45 is 66. What's this whole thing? X plus 5x is 6x. So we'll start up here because I don't know how much room we're going to have. We're going to have 21 times 66 equals 6x times x. 6x times x is 6x squared. And I'm just going to leave this 21 times 66 because it makes it easier for me. If I divide both sides by 6. Now the reason I'm dividing both sides by 6, even though it's quadratic, is because I'm missing an x term, which means I can get x squared alone and then just square root both sides. So when I divide this by 6, those cancel out. 6 goes into 66 11 times. So now I have 21 times 11. And if you remember the shortcut for 11, 21 times 11, you split up the 2 and the 1, the 21, and then you add them together and put it in the middle. 2 plus 1 is 3. And you can do that on your calculator. I just like to do it a little quicker than that. So we are going to square root both sides. Now, if you remember up here, that's a 21 and 11. That's 3 times 7 times 11. Those are all prime, and nothing is a perfect square factor. I don't have any common factors. This is just 3 times 7 times 11. So I don't see any two factor that's the same, any factors that are the same. So I know that I can't simplify this square root anymore. So the answer is just the square root of 231. And that's the exact answer, which unless it says to round, we're always going to do the exact answers. Okay, we got some square roots over here too. So remember, inside the circle, so part times part, part times part. So the product of these two equals the product of those two. So 15 times x, that's pretty easy, 15x. But what are these two multiplied together? Remember, when you multiply square roots, it's outside times outside, inside times inside. So 4 times 3 is 12, and the square root of 5 times the square root of 5 is the square root of 25, which then the square root of 25 is 5. And if I divide both sides by 15, 5 goes into there 3 times and 5 goes into there once, and then 3 goes into there 4 times, so the answer is 4. But if you wanted to do it, you wanted to do 12 times 5 divided by 15, you would also get 4 if you did it on your calculator. Okay, and it said find x, and I found x. Okay, last example for today. Whole thing. What is the whole thing? Well, x plus 6 plus 3 is x plus 9. So we have 3, which is the outside part, times x plus 9, which is the whole part, equals the whole thing, which is x, times the whole thing, which is another x. Times the outside part, which is x. So 3x plus 27 equals x squared. That's a quadratic equation. So I'm going to get everything on one side. X squared minus 3x minus 27 equals 0. When I think of factors of 27, that's 9 and 3. 9 and 3 don't subtract to get me 3. So this is going to have to be a quadratic formula. So I'm going to make sure I know that a is 1, b is negative 3, and c is negative 27. So the a sits in front of the x squared, b here, c here. So I'm going to say I'm going to sing my song. X equals negative b, that's the opposite of b, plus or minus the square root of b squared minus 4ac. A is 1, so I'm just ignoring it. All over 2a. Again, a is 1, so 2 times 1 is just 2. When I multiply these two together, those were both negative, and two negatives right next to each other like that, when you're multiplying, it's going to get you a positive. So I'm going to say 9 plus 4 times 27, and that is 117. Now, 1 plus 1 plus 7 is 9, so I think that's divisible by 9. So this becomes 3 plus or minus, I don't think I made you do this in class, but it's the square root of 9 times 13 over 2. And the square root of 9 would be 3 plus or minus 3 square roots of 13 over 2. And though that would be my answer, obviously I'm going to ignore the negative. So I would just do the 1 plus, because it can't be negative. That little part can't be negative. Now, if you wanted to estimate that, we can do that real quick. 3, I'm going to put it the top all in parentheses. So 3 plus 3 square roots of 13, and parenthesis on the square root, and parenthesis for the top of the fraction, and then divide by 2. So that's approximately 6 point, depends on what you're rounding to, 9.1 if we're rounding to the hundredths. So that's approximation. And so you just have to look at the directions to see. Okay, so remember those two formulas. Chords inside, part times part equals part times part. But outside, if it's two secants or tangent and a secant, then it's whole times outside equals whole times outside. Good luck. M squared signing out.